Hey everyone, so please again welcome on my YouTube channel. And in this session, I'm going to start with one more new method. Depends on the analytic functions, that what is analytic, what is CR conditions, and all. And before starting today's session, let me highlight some of the previous sessions. And in the previously we did we have just completed the limit method, and before that we did the representation of the complex numbers, that how we can separate into the real and into the imaginary parts, right? So guys, let's start with our today's session. So I'm writing, you can see the method is given here. The necessary condition for f of z to be analytic. So to be analytic functions, what is required and what don't, okay? And based on this, we will do a little bit examples that how we can identify for which points the given function is analytic or not. That we will do in our today's sessions. And this one is very much important, guys. And here I'm giving all the theories of analytic, okay? That how we can find analytic functions, and how it will be not analytic, or how it will be singular functions, and what is sufficient and necessary conditions to be an analytic functions, okay? It is actual known as CR conditions. So we are going to start with these all the topics. And see, the highlights is given the necessary condition for f of z to be analytic, यानी कि it is actual known as Cauchy-Riemann partial differential equations. So here I have written its definition. If a function f of z equals to u of x plus iy plus iv is analytic at any point z equals to x plus iy, then f of z का फंक्शन अगर एनालिटिक है, that is at which point, that is at the point z plus iy, then the partial derivatives यानी कि ux, uy, vx and vi should exist. This all you have to find, guys, okay? ये सब आपको यहाँ पे find करना है पहले. That should exist, वो सारे के सारे exist होने चाहिए and satisfy the equations. एक इक्वेशन है जो आपको वो सेटिस्फाई करना है, एंड विच इज नोन एज Cauchy-Riemann equations, and the equation is given into the form, I'm highlighting, guys, ux equals to vy and uy equals to minus vx, okay? So ये दोनों equations है that you have to that must be satisfied, and this equations is known as CR equations, or else we can call as Cauchy-Riemann equations, okay? And this one particular we will do for the examples. So this one is a definition to be an analytic functions. The sufficient condition, and here I have given its sufficient condition for the function f of z to be analytic. The continuous single valued function f of z is said to be analytic in the domain D if the partial derivatives यानी कि ux, uy, vx and vy exist, are continuous. वो सब exist होने चाहिए, और वो सारे के सारे कैसे होना चाहिए, that must be continuous and again satisfy the CR conditions यानी कि Cauchy-Riemann conditions at each point of the domain. जो भी डोमेन यानी कि जो स्पेसिफिकली आपको जो इंटरवल दिया है उसके लिए, ओके? जो भी पॉइंट्स आपको दिया है फॉर दैट components. And or else we can write in another words, like for function f of z equals to u plus iv, if the partial derivatives यानी कि del u by del x, and this one is actual your ux only, it's nothing but ux. Same del u upon del y, del u upon del y, and it is nothing but uy. Same vx and vy are continuous in the region R, and again CR condition must be satisfied, then it is said to be an analytic functions. So the necessary condition for a function f of z equals to u plus iv is to be analytic functions at all the points in the region R, which one is ux equals to vy and uy equals to minus vx. So this one is your Cauchy-Riemann equations. This one is condition for the Cauchy-Riemann and this is for the Cartesian form, and now we are doing for the polar form. Okay, so यहाँ पे मैंने जो लिखी है this is for given for the polar form. So if z equals to f of z equals to u plus iv is an analytic function where u and v are functions of r and theta. अभी यहाँ पे आपको u and v that will be in the terms of r and the theta, because of course then and only then we can call it for polar form, right? अगर वहाँ पे r और theta दिए ही नहीं then we can't say about polar form. So u and v will be given in the form of r and theta, and that equals to, you know now, r e raised to sin theta. Then del u upon del r will be 1 upon r into del v upon del theta, and for the another one del u upon del theta, that will be minus into r del v upon del r. So this I'm highlighting guys with the pen. Okay, this one and this both are very important to solve the examples. So please keep it in your mind, these both the formulas. Okay, and now I'm starting with the examples. And here the questions is given, find where each of the following functions to be analytic. So you have to find which functions are analytic and which are not. If analytic, then at which point it is analytic, and if not, and then which points this is not analytic. That all concepts you have to say here. So there are given total 4 examples. Let's start with the A part. And the function is given f of z equals to z upon z square minus 4 equals to, I'm just giving it one name, f of z. Then you have to find its first derivative. Okay, so इसका हमें find करना है first derivative. So to find its first derivative, definitely you have to apply its quotient rule, and quotient rule यानी कि division rule. In Gujarati we can say that ભાગાકારનો નિયમ, right? That you have to apply. So doing this and giving a simplification, you will get this function for the first derivative. And to find some specific analytic point, you have to apply denominator equals to 0. And see the denominator, don't go on this concept. Okay, इसमें जाने की जरूरत नहीं है. So to find the analytic point, you have to apply denominator equals to 0. So z square minus 4 whole square equals to put 0, and definitely to solve by solving this equation you will find the values of z, and it will be z equals to plus or minus 2. Okay, so f dash does not exist because here we are getting a values of z, so we can say that the f dash of z does not exist. It means we can say that f of z is not analytic at the points z equals to plus or minus 2. It means what's actually it's want to say, in place of z, if we will put z 2 or minus 2, then it will be 0. You can see that guys. अगर आप यहाँ पे 2 और माइनस 2 पुट करोगे तो 2 माइनस 2 स्क्वायर यानी कि 4 माइनस 4 0. सो न्यूमरेटर अपॉन द 0 यानी कि दैट गोज टू इनफाइनाइट. सो इसीलिए मैंने यहाँ पे लिखा था गाइस इनफाइनाइट. ओके, सो डेफिनेटली इट विल बी इनफाइनाइट. सो फॉर दिस पॉइंट यानी कि प्लस और माइनस 2, इट्स नॉट एनालिटिक पॉइंट, वी कैन से दैट. ओके, सो एक्सेप्ट दिस ऑल दी नंबर्स यानी कि प्लस 2 और माइनस 2 के सिवा जो भी नंबर्स आते हैं वो सारे के सारे एनालिटिक्स है, वी कैन से. So the given function is not analytic at the point +2 and the -2, and except these 2 points the given function will be analytic. Okay, so this one is very much important concept to understand, guys, that how can find the point at which point the given function is analytic and not. Okay, so if we will put 2 and -2, अगेन रिपीटिंग गाइज, कि अगर हम लोग डिनोमिनेटर में जो z की वैल्यू मिल रही है, अगर वी विल पुट हियर इनटू द डिनोमिनेटर, देन डेफिनेटली इट विल बी 0, एंड कोई भी नंबर्स अपॉन 0 यानी कि दैट गोज टू इनफाइनाइट, सो विच इज नॉट पॉसिबल. सो ये दो नंबर्स एनालिटिक नहीं है. इट मीन्स द फंक्शन इज नॉट एनालिटिक एट द पॉइंट 2 and -2, because if you will put 2 and -2, then it will goes to infinite. Okay, so except these 2 points, the rest of all the numbers will be analytic. Now moving forward for the second one, f of z equals to z upon z minus I. So again with the same procedure, first of all apply its first derivative, and then put solving, put denominator equals to 0, and as you are getting here z minus I whole square equals to 0, so the z will be I. So of course we can say that for the I, for the point at the point I, the given function is not analytic. तो I के पास ये आपका function analytic नहीं है, और except the I, that will be analytic. Now see the third one, f of z equals to 2z upon z square plus 1. So again you have to do with the same procedure, and here you can see that z square plus I. Okay, and if you will find f of first of all you have to find f dash of z, and then after denominator equals to 0. So then also you can find the at which point we will get analytic or not. Or else if you want to find singular point, then what is singular point? At which point the given point given numbers is singular. So to find this, again you have to do with the same procedure, that to find the singular points you have to put denominator equals to 0 directly. And as you know all, denominator is coming here z square plus 1. Okay, so that's z square plus 1 equals to 0, yani ki you can say that z equals to plus or minus I. See here I have written, so this will be your singular points, and I hope you all might be aware that how to find singular points, that we did in the second semester in the power series. Okay, so to find the singular points, again repeating, you have to put denominator equals to 0. So here you are getting z equals to plus or minus I as an singular point, and definitely that will be your analytic numbers also. So at this point, this one is analytic, it's not analytic, and rest of the point it will be analytic, right? So यहाँ पे हमारे पास दो वैल्यूज है z की, दैट इज प्लस और माइनस I, तो वो दो नंबर्स के पास दैट इज नॉट एनालिटिक, एंड rest of the numbers it will be analytic. And same here I have written a fourth one, that we have f of z equals to z square plus 1 upon z plus 2 into the z square plus 2z plus 2. Okay, so with the same procedure you have to find see यहाँ पे f dash of z find करना थोड़ा ज़्यादा tough है, right? इसका first derivative, then it will be too much tough. So for that directly you can use this method also, that directly you can apply denominator equals to 0, यानी कि z plus 2 0, and यहाँ पे आएगा z square plus 2z plus 2 equals to 0. Okay, So putting this, and after the simplification you will get the values of z. Okay, so this one is not analytic. So for the given point, as we are finding here, so for this point, this one will not be analytic function, and rest of the given points, yani ki rest of these points, the given function will be analytic. So see guys, if it is hardest to find the first derivative of the denominator, then directly you can apply denominator equals to 0, and then you can find its solution. Okay, and solution is actual known as your singular points or else analytic points. Okay, so if it is easiest to find its first derivative, then go through the A and B examples, and if it is not easiest to find, if it is hardest to find its first derivative, then you can move on from this, yani ki C or D, yani ki you can use the method C and D form. Okay, now next one, the equation is given, find the real and imaginary part of f of z. Okay, so in place of z, ये वाली method already हम लोगों ने की है. So hope you all can do the practice now, because in place of z you have to just put x and y, right, yani कि x plus I y, and solving this definitely you will and separating the term, after the separating definitely you will find real and the imaginary parts. And see the third one. Third one is again same question, that find the real and imaginary parts of f of z equals to 2z cube minus 3z. So again with the same procedure, in place of z you have to put x plus iy. Okay, and then after separating you can find real and the imaginary parts. And I have not written, but the answer I have written here. You can check it out with your own self after after solving the examples. Okay, guys. So in next session, I hope you would like my today's session, and hope you all understood very well. And please don't forget to subscribe and like my channel. And in next session, we will again start one more new method. Thank you, guys.